Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P2421 specifically references the EVAP canister vent shut valve being stuck in the open position. The EVAP, or Evaporative Emissions Control System, is crucial for preventing fuel vapors from escaping into the atmosphere. This system includes various components that work together, including the EVAP canister vent shut valve, which is located near the fuel tank. It regulates the flow of vapors from the fuel tank to the canister for absorption before those vapors are sent to the engine for combustion. If this valve is stuck open, it can cause issues such as increased emissions and difficulty in fuel tank pressure management. Understanding this fault is essential, as it can help improve vehicle performance and lower environmental impact. The EVAP canister vent shut valve plays a critical role in regulating vapor flow from the fuel tank to the EVAP canister. This valve is situated under the vehicle, typically near the fuel tank, where it manages the passage of emissions to ensure that harmful vapors do not escape into the environment. When functioning correctly, the valve opens and closes as necessary to control vapor release. However, when the valve is stuck open, it can lead to poor engine performance, fuel buildup, or even excessive emissions. This issue is captured by the DTC P2421, indicating a need for thorough inspection and potential repairs to the valve or its associated components. Accurate diagnosis is crucial to restoring optimal functionality to the EVAP system. Diagnosing the issue related to DTC P2421 can often point to several possible causes. First, there might be an intermittent electrical failure affecting the EVAP components, such as poor connections or loose terminals. This sporadic behavior can prevent the valve from operating properly. Secondly, a blockage in the vent hose can restrict vapor flow, leading to the malfunction of the valve. Lastly, damage to the fuel tank vapor recirculation tube can also be a contributing factor, as it may impede the system's function. Identifying these causes is essential for targeted troubleshooting and repair, ultimately ensuring the EVAP system operates as intended to minimize emissions and enhance vehicle performance. The presence of DTC P2421 typically manifests through several noticeable symptoms. One immediate indication is the illumination of the check engine light on the dashboard, signaling that the vehicle's onboard diagnostic system has detected an issue with the EVAP system. Additionally, drivers may experience poor fuel economy, as the malfunctioning valve can lead to inefficient fuel usage. Excessive emissions are another critical symptom, which may make the vehicle non-compliant with environmental regulations. Understanding these symptoms can aid in early diagnosis and intervention, ultimately preserving the vehicle's performance and reducing environmental impact. The first troubleshooting step involves confirming the fault. Begin by turning the vehicle to the on mode without starting the engine. This allows the electronic control unit, ECU, to perform necessary diagnostics. Next, use the Honda Diagnostic System, HDS, to clear the DTC from the memory. Following this, select the EVAP test option in the inspection menu of the HDS, and then proceed to the function test. Depending on the results of this test, you can ascertain whether the failure is intermittent or if it has been successfully duplicated. If the system returns with the same DTC, it will denote that further investigation is necessary. In the second step, gaining access to the EVAP canister vent hose is essential. Start by removing the right front floor undercover, which provides access to the EVAP components. Once this cover is removed, inspect the EVAP canister vent hose for any blockages or restrictions that could affect its operation. Such hindrances could easily prevent vapor from properly exiting the fuel tank, thereby causing erroneous DTC reports. If you indeed find a blockage, remove it. If the hose itself is damaged, it should be replaced to restore proper function to the EVAP system. Ensuring that the vent hose is clear is critical for the overall health of the EVAP system. The third step focuses on the fuel tank vapor recirculation tube. It involves checking for poor connections or signs of damage at this critical component. This tube connects the fuel tank to the EVAP system and is crucial for efficient vapor recirculation. Any issues here can extensively affect the EVAP process and contribute to the error indicated by DTC P2421. If everything appears to be intact, you can move on to the next step in the troubleshooting process. However, if you find any signs of damage, address them by replacing the tube or validating that it is secured correctly. This step ensures tight seals in the vapor system. Step 4 involves checking the EVAP canister purge valve for any leaks. Remove the valve while keeping its connector and vacuum hose attached. Next, you will disconnect the vacuum hose from the valve and connect a T-fitting along with a vacuum gauge and a vacuum pump. Apply a minimal vacuum of approximately 2 kPa to test if the valve holds it for 1 minute. This step is crucial because a failure to hold vacuum indicates an issue with the purge valve, potentially requiring a replacement. If it passes the test, the system is moving forward to the next steps, having confirmed that the purge valve is functioning properly during this troubleshooting process. Step 5 involves disconnecting the fuel vent tube from the EVAP canister. This action requires turning the vehicle to the off or lock mode to ensure safety during repairs. Once the vehicle is off, carefully disconnect the fuel vent tube and plug the EVAP canister port to prevent contamination or leaks during the testing process. You will then connect your vacuum pump to a designated hose to further examine the EVAP system's integrity. This procedure should help isolate the problem area, either confirming that the vent shut valve is at fault or ruling it out for other potential issues later on. In the 6th troubleshooting step, you will assess the EVAP canister vent shut valve by utilizing the EVAP test feature again within the HDS. This time, select the EVAP CVS off option to gauge whether the valve operates correctly. Disconnect the hose from the vent valve port and ensure that it is plugged properly to facilitate a controlled test. Apply vacuum to the system until the fuel tank pressure (FTP) sensor reads 1.90 volts, ensuring you do not exceed recommended vacuum levels to prevent any sensor damage. After 1 minute of monitoring, check if the FTP voltage increases by more than 0.2 volts. A positive result indicates that the valve is functioning properly, while failure to meet this requirement suggests that the valve needs replacing to maintain proper EVAP operations. Step 7 focuses on thoroughly inspecting the EVAP canister purge line and the canister itself. This involves checking for poor connections along with any physical damage that may impede vapor flow. If either the line or the EVAP canister shows signs of wear or damage, you should replace the affected component. These checks are essential, as they ensure that no leaks or interruptions occur in the line that could jeopardize the overall functionality of the EVAP system. Any overlooked damage may compromise the entire process, leading back to the same DTC. Keeping these components in peak condition is vital for optimal vehicle performance and emissions control. In the 8th step, you will need to visually inspect the fuel fill pipe and the fuel tank vapor recirculation tube. Focus on identifying poor connections or visible damage in these areas, as any flaws can cause the entire EVAP system to malfunction. This step is crucial in determining if further replacement is necessary. If a significant issue is detected, you should replace the tank or the fill pipe as needed. This ensures a tight seal and proper functionality. contributing to the overall integrity of the evaporative emissions control system. Confirming that these components are both really in good condition will be essential to preventing future DTC occurrences. The ninth step of troubleshooting revolves around evaluating the shutoff valve. Begin by removing the misfuel inhibit device, which can impede access to the valve's mechanism. Next, examine the flap of the shutoff valve closely. It should be in the closed position. If the flap is not closed, it indicates a malfunction, and the main flap unit must be replaced to ensure proper sealing and functionality. The shutoff valve plays an essential role in preventing fuel spillage and vapor escape, so confirming its integrity is vital for the EVAP system to function as designed. Addressing this component promptly can mitigate further complications related to emissions and fuel management. The last troubleshooting step requires an inspection of the shutoff valve seal. It's important to check both the flap seal and the mating surface to verify they are not compromised. A missing or damaged seal could lead to improper sealing, further contributing to the DTC P2421 issue. If any issues are found with the seal or its mating surface, the main flap unit should be replaced to restore functionality. Additionally, checking the fuel tank unit O-ring is crucial, as a faulty O-ring may further exacerbate sealing issues. In this final step, ensure that every component is functioning optimally to guarantee long-term reliability of the EVAP system. Upon completion of all troubleshooting steps, it is essential to conduct a final repair verification to ensure that the issue has been successfully resolved. Initiate this process by testing the overall functionality of the EVAP system, making sure all components are working in harmony as intended. Following this functional test, clear the DTC from the vehicle's memory using the HDS. After clearing, take the vehicle for a test drive under varying conditions to confirm that the DTC does not reappear and that all symptoms have been alleviated. This thorough verification step is crucial, not only for confirming repairs, but also for solidifying the reliability and efficiency of the vehicle's EVAP system. Preventive maintenance can play a significant role in avoiding issues related to DTC P2421 in the future. Regularly inspecting the various components of the EVAP system, including hoses and valves, can identify potential problems before they necessitate major repairs. Additionally, maintaining the fuel system is vital. Ensuring that fuel tanks are not overloaded and that fresh fuel is used can help mitigate excessive pressures that may affect the EVAP components. Proper sealing is paramount in the evaporative system. Make sure connections and seals are intact and functional. Engaging in these preventive practices will enhance the longevity and performance of your vehicle's evaporative emission system. In conclusion, DTC P2421 points to a malfunction with the EVAP canister vent shut valve, highlighting the need for thorough inspections and corrective actions. By carefully troubleshooting and addressing each potential issue, mechanics can effectively restore functionality to the evaporative emissions system, ensuring reduced emissions and improved performance. Preventive maintenance is also vital. Regular checks and proper fuel management practices can prevent similar issues from arising in the future. Attention to these details not only enhances vehicle reliability, but also makes a significant positive impact on the environment. Focusing on proactive measures can ultimately lead to a more efficient and durable system. Please like and subscribe to the channel. See you next time.